The next page is about the factors affecting intermolecular forces. So I'll just do I'm just gonna combine the London, dipole and hydrogen bond factors. Okay, the first factor is molecular size, which equals to the molar mass. So the higher the molar mass, the stronger the van der Waals or hydrogen bond. So the higher the boiling point. For example, okay, for van der Waals forces, so let's say we have Br2 and I2 gas. So first thing first, you have to calculate the molar mass. Okay, so for Br2, that would be 159.8 gram per mole. For I2, that would be 253.8 gram per mole. So which one has the higher molar mass? Yes, that would be iodine. So iodine has a stronger van der Waals forces, hence higher boiling point. Okay, so write down your notes. So I2 has higher molar mass. So it has higher boiling point. So second is for hydrogen. Okay, so look for hydrogen. So we have CH3, CH2OH and CH3, CH2, CH2OH. Okay, and the molar mass would be 46 gram per mole and 60 gram per mole. Okay, so obviously CH3, CH2, CH2, 1, 2, 3, try CH3, CH2, CH2OH would has a higher boiling point than CH3, CH2OH than ethanol. Okay, again, you have the same point as above. So CH3, CH2, CH2OH has higher molar mass, then it has higher boiling point. Okay, this BP stands for boiling point. Okay, it is not blood pressure. Okay, I don't teach you about blood pressure in chemistry. Second is the molecular shape. Okay, so linear molecule has greater contact surface area, so it has stronger van der Waals or hydrogen bond. Okay, so it will later on has higher boiling point. So for example, for van der Waals forces, we have these two. Okay, copy down the next one. Okay, so compare between these two molecules. Okay, so this is in linear form, while this is in branch form. Okay, so which one would has a higher boiling point? Okay, yes, the linear one. Okay, because linear has greater contact surface area, so it will have stronger van der Waals forces, so and then higher boiling point. But what about what if I change this linear, and so this linear structure, I'll just change CH3 into OH, and the same thing goes for branch as well. Yes, so still the same thing happen. Okay, linear hydrogen bond will has a greater contact surface area than the branch one. So next, the third factor is the molecular polarity. So molecular polarity, it depends on the electronegativity of an atom. So the higher the polarity, so the stronger the van der Waals forces or hydrogen bond. So the higher the boiling point will be. Okay. So for example, for van der Waals forces, we have CH3F and CH3I. Okay, make some correction on the lower subscript. Okay, so the difference is between the fluorine and iodine. So which one has the highest electronegativity, class? Okay, always remember font. Okay, so F has higher electronegativity. Okay, so CH3F will has higher boiling point than CH3I. Okay, so make a sentence on it. So CH3F has higher boiling point as F is more electronegative than iodine. Okay. So for hydrogen bond, so let's say we have hydrogen bond of HF and NH3. So again, F is more electronegative than N. So HF will have higher boiling point than NH3 because fluorine is more electronegative than nitrogen in this case. Just a look at the font trend. Okay, F, remember F is the most electronegative element in periodic table. Okay, so F is more electronegative than nitrogen. Okay, class. There is the fourth factor which is only applicable for hydrogen bond. Okay, which is you have to consider the number of hydrogen bond formed. Okay, but beware, this is only applicable if you want to compare between two molecule that has hydrogen bond. So let's compare it between this molecule that has two OH on it. So this molecule is called diol. Okay, di means two OH. With this CH3, CH2, CH2, OH molecule. Okay, so notice that this diol structure has two hydroxide, so it can form two hydrogen bond. Meanwhile, this structure only has one hydroxide or hydroxyl group, so it can only form one hydrogen bond. Okay, in short, you can say that the first structure can form two hydrogen bond, while structure 2 form one hydrogen bond. Okay, the higher the hydrogen bond exists, the stronger the intermolecular process. Okay, so add on this fourth factor, but please remember that it is applicable only for hydrogen bond. Okay, and for the whole summary class, okay, so the first factor that you have to consider is the molecular size or molar mass, and if the two molecules has same molar mass, then you have to look at the second factor, which is the shape. But if the shape is also the same, then you have to look for the third factor, which is polarity. Okay, and the fourth factor is when you are comparing the hydrogen bond, first you have to calculate how many hydrogen bond can a molecule exist, can a molecule develop.